Hey everyone, and welcome to another simple science video. And in this video, we're going to talk about covalent bonding. It's part one of our two-part series on covalent bonding. Alright, so covalent bonding is basically a type of bonding, just like metallic bonding, which we talked about in the previous video, that exists between inside molecules made up of non-metal elements, such as a chlorine molecule. There is covalent bonding between there, and a sulfur dioxide molecule, a more complex compound. Alright, but in this video we are going to be only talking about simple molecules, basically molecules made up of only one type of element, like chlorine. A chlorine molecule is made up of only chlorine atoms. Alright, and elements, they form covalent bonds by sharing electrons, alright, where the atoms covalently bond so that they can attain a stable arrangement of complete outer shells. That basically means the electrons between atoms, they arrange so that when their shells overlap, you basically have an atom within the covalent bonded structure that has a full outer shell. For example, the full outer shell for hydrogen is 2 electrons. So when we try to combine two hydrogen atoms where it originally has only 1 electron in its outer shell, you basically now have an atom or set of atoms joined together covalently so that each hydrogen atom will have 2 electrons in its new electronic structure. Alright? And when you look for chlorine, you basically have 2 atoms where there are 7 outer electrons, and you basically have to join them together in order to get a structure that has a stable octet. Okay, so in doing this, chlorine will form a single covalent bond within its molecule. Alright, so that each chlorine atom within the molecule will have 8 electrons surrounding it. And the main purpose of this is to achieve the outer shell arrangement of a noble gas. Alright, it is the most stable. The electronic structure of a noble gas atom is the most stable. Alright, so elements naturally tend towards this. So when we observe chlorine in nature, in real life, it will naturally exist as 2 atoms forming a chlorine element because it's tending towards stability. Alright, and talking about noble gases, what we basically have is that chlorine in its outer shell, where we just basically, or if we like, we can count the total number of electrons in its atom now that it's covalently bonded. It will have a total of 17 electrons, where 16 come from the original chlorine element, add 1 electron from the other chlorine atom covalently bonded to it. You have a total of 17 electrons, and that is electronically equivalent to the total number of electrons in an argon atom. Alright, so that's where we get the idea of tending towards noble gas structures, such as how hydrogen would tend towards a noble gas structure of helium. Alright, and oxygen also. And the only thing different in this time is that the oxygen molecule will have a double bond, and it must share 2 electrons each in order to have that full 8 octet structure. Alright, and when it does so, the electronic structure around each oxygen atom will be equivalent to that of neon. Alright, and you can also form triple bonds, such as how nitrogen gas will exist in real life. Okay, now that's it for simple molecules. And to quickly summarize this video and to quickly basically give a quick tip on it, I'm going to talk about how you can show notation on these molecules. So if there's a single bond within a molecule, we represent it with 1 dash. When we have a double bond, like an oxygen, we have 2 dashes. Alright, triple bond, basically 3 dashes. It's very simple. Alright, so thank you very much for watching my video. Please watch the next video, the part 2, to learn about more complex molecular compounds that have covalent bonds and the shapes and properties of these molecular covalently bonded compounds. Have a nice day, everyone.